We're going to be writing another macro today. I'm going to speed through this a little more quickly than last time. We won't be explaining every facet of the macro system because we covered that a little more in depth in the prior video, which I'll link to somewhere, or I trust you to navigate YouTube as well. Today we're going to be writing a macro to derive any wrappers, these sorts of any blank wrappers, which you might have seen around. If I import SwiftUI, there's this any view thing which serves to erase the type of the view inside of it. Let's motivate this a little bit. It's going to be contrived, but it's the best we can do quickly. Let's say we have a protocol. We'll need a protocol. This protocol is going to have an associated type called value. So we're making a box. This box is very simple. It has one get function on it, and this will get us back that associated value type. Perfect. Now we'll need some concrete structs which implement this protocol. So we're going to be making a little box DSL. So here's going to be called value box. It's going to be parameterized by a value, and it's going to conform to box. It will store its value, and its get method will simply return its value. It couldn't be simpler. So we can have ourselves here a string box. This will be a value box with some string inside of it. The standard ubiquitous coding tutorial string there. And so if I call stringbox.get, we will get the hello world contained inside of it. Brilliant. Show-stopping. Next up, we might want to introduce a map function, so I can perhaps map over this and grab out the count, the size of this string, and print that out. In order to do this with a little protocol-based DSL like this, I'm going to make another struct called mapBox, which will have two type parameters. The box we're mapping over, and then the target value we are extracting from this. This must conform to box as well. We'll store the original box B, as well as the function that will take B's value and project out our new target value. So in this case, our get function will simply get the value out of B, and then transform it with our little f here, getting our value. And to make this nicer to work with, I'm going to write an extension on box called map, which will be parameterized by value2, and it will take this function from our value to value2, and it will return a map box of self and value2. And what this is going to do is it's going to simply construct a map box, putting ourselves in this side and putting f in there, and this will therefore be escaping. So now the code I wrote down here will work, and we can, well, call get after mapping here, and get 13, which is the length of the string. So we've built this very pointless DSL, and we have just enough complexity in place to run into our problem. I'm going to abstract this string count box, and then I'm just going to create a lucky number box, and this is simply going to be a value box that wraps the number 386. Great. So now both this lucky number box as well as the string count box, they both return ints. In some abstract sense, they are both boxes whose associated type is int. And it would be great to view them as the same thing. So maybe I could say int boxes like this and put string count box and lucky number box in here. Unfortunately, this doesn't quite work. Heterogeneous collection could only be referred to as any, so yeah, we can view them as any. That's not great. We could throw literally anything in here now. It would be much better if we could view these as boxes of int. That's conceptually what we want. However, protocol box does not have a primary associated type with which it can be constrained. That's an interesting error. So a few Swift versions ago, there's this new feature known as primary associated types, which sort of gets us towards a happy end, where you have to awkwardly rewrite the associated type up here, and then you can write it down here. But now we have to do this other step known as a boxed protocol type, which is a little any keyword, and throw that in front of this. And this seems to work. It's pretty cool. I mean, it's not that cool. It's wild. We had to use a few weird features to get this to work, but it does work. So I can say for int box in int boxes, and then I can say let value equals int box dot get, and the compiler knows this is an int. I can print the result of it. I can add 100 to each, and we'll see that we get those two values. That's all very cool. What if we wanted to do something else? What if we wanted to make an is-even box in here? So is-even boxes. I can do it like this. I could say int boxes dot map, int box in, int box dot map, And theoretically, I should be able to say, is it divisible by 2? However, we get this strange error. Member map cannot be used on value of type AnyBox int. Consider using a generic constraint instead. So it gets us a little further, this boxed protocol type combined with this primary associated type, I forgot the name. A lot of weird features that sort of get us closer to something that just works as we would conceptually ideally like it to, but they both have their problems. And when you get into a certain level of complexity, everything just falls apart. And these are partial measures. We want something that will work in every case. And so this is why they have these AnyBox types. We want to make this sort of thing. It has its own compromises, but we want to make this. So cannot find AnyBox in scope. So this sort of type erased wrapper thing, generic wrapper, what is this going to be? It's going to be a struct, AnyBox. And it's going to take once more a value constraint, and it's going to inherit from box. And the way this is going to work, the way we're going to implement get, it's awkward. We want to initialize ourselves with some other box, right? We're wrapping those other boxes, as we've seen. So we're going to take some box of B, and we're going to have to say where this box's value is equal to our value. Though technically, because we have this primary associated type, we can also do this. But we won't always have those primary associated types. In fact, I'm just going to remove it so we focus on the already complex space we're dealing with. Okay. And so we're going to construct this with some box. You might think, okay, I can maybe store this box off, right? But what box are you going to store here? This is exactly the sort of situation that's problematic. We can't store just a box of value. We could maybe if we had primary associated type and brought that back in, and then we could store an AnyBox of value potentially. So self.box equals box. Technically, this does work, but this will only work if there is a primary associated value, and we don't want to box ourselves in there. So let's ignore that potential approach. Remember, we want to eventually make a macro that does this for us. That's why this is a macro video. So we don't want to force our users to give their protocols primary associated types if they don't want them. So the other way, like what is a box really? The only thing we would ever get out from this box, it did have a primary associated type, we would call this get method on it, this get function. So if that's really all there is to a box, why not just store that instead? We can store the get function and say self.get is equal to box.get. Then we can call this stored off get function, and that works. It's weird, for sure, but it works. We're basically tearing apart like some vicious animal, this initial protocol box thing that doesn't quite suit our needs. So we're going to disembowel it and then store its bowels in these jars, these variable jars filled with embalming fluids and whatnot. And then we're going to carefully take its bowels out of the jars and put them into ourselves and walk around saying we're that box. It's all very morbid, at least this particular metaphor, which I will now abandon. And then to make this a little nicer to use, we can make an extension on box called as AnyBox. We can just say AnyBox value and throw ourself in there. So now at the bottom, where this is sad, we're unfortunately going to have to write as AnyBox, but now everything works. We have these is-even boxes, and we can print is-even boxes map get and see that false and true are the answers, as the values are in fact 13 and 386. Okay, still not the most beautiful ergonomics in the world. It's just one of the realities of Swift at this moment where, unfortunately, that any keyword breaks down in some situations. Maybe they'll fix that. That sure would be great. Theoretically, Swift is doing that same sort of thing when you use that any prefix. That's why it's called a boxed protocol type. You're essentially making a wrapper that you're putting the initial value inside of and proxying calls to its functionality. But yeah, there are weird limitations where once it is an any box, you can't then treat it as a box. We couldn't put it inside of mapbox, for instance. So this any pattern lives. However, it has a downside, which brings us to the purpose of this video. It is verbose. It is verbose and a little weird and easy to forget. And you've got to write some boilerplate. Some boilerplate that will change with the strictures of your protocol, with the requirements of the protocol. If we were to add a new method here called get twice or something silly like this, then we would need to store off get twice and assign it here and define the actual protocol method. So it's fully derivable. And I will now get rid of this because we didn't implement it everywhere and that's confusing anyway. So I'll do all that. But the point is, this implementation is purely mechanically derived from the protocol, which is a perfect case for a macro. We can only screw things up by doing it ourselves and waste time. So let us think about this. How can we macroify this? We have the target end state in mind, which is we talked about last time. We did it manually. We have the target starting state in mind, which should be something just like one of these annotation macros. Derive any wrapper or something like that. I'll stick with this for now. So the start state will be simply your protocol with the annotation, and the end state will be these structs and extensions that are created. Is this possible? I think so. I haven't written this code yet, actually, so we'll find out together. I really hope so. Otherwise, this preamble would have been wasted. But let's get in there and see what we can do. But first, let us think what we need. Actually, that's a good thing to think about. What kind of information, before we get into all the wild syntax of macros, what things do we want to extract from our box syntax that we're going to use down here? What kind of functions might we write? Let's try to break this apart ahead of time. We clearly need the identifier. So the protocol identifier, not sure how to get that yet, but I'm sure it's something like protocol declaration, and it has a .identifier method on it somewhere, similar to how a struct had an identifier. And then we need all of its associated types. All of its associated types. Now, the associated types can have some complicated elements here. They can have their own sort of protocol conformance requirements, but let's just not worry ourselves with that just yet. So we want to get the associated types, and then we want to get all of its function declarations. And potentially also we want to get its getters. I don't think we can really deal with the setters correctly in this manner. We would have to create some kind of reference type box and stuff. It would all get very complicated. And in fact, I'm not even sure if we're going to deal with these getters, but basically these can be handled very similarly to the function declarations. So let's just simplify things and forget about that detail. So all of its function declarations, its associated types, and its identifier. And that's really all we're using. We're using the identifier here. We're going to need to list its associated types as parameters. This line is basically just derived from the identifier and the associated types. And then for its function declarations, well, we will need the function's name as well as its signature. So its input types and its output type. So the name is really all we would use here. For each function, we're going to need to create an underscore prefixed version. So basically we want to add a member called var underscore function name, colon, and then we want some kind of signature, some kind of function signature, which isn't going to be exactly the same thing as the function signature, right? Function signatures can have labels, but when turned into a function value like this, those labels are going to go away. So we need to generate this somewhere. So for each function f, we're going to add this member, that is the function name, and some signature. And we also need to sort of generate this signature by taking the function signature and then creating this function value signature. So generate signature from function declaration signature. And then also for each function, we want to actually declare the function. So define the function, and we want to internally call our underscore prefixed variable. And I guess now that I think about it, that can just be a let. That will never change. And if it does accept arguments, so get could have taken, once again, arguments, label string, this would have been string, then we want to pass those arguments along in order. So we'll need to pass arguments along in order. And that can be our guide. Maybe we'll use this to create some helper methods. We can work from the top down and the bottom up. Burn the candle from both ends is always something I like to do. We've already done that a little bit by burning the candle from the top, our ideal syntax, and then the bottom, envisioning our final ideal target state, the code we would like generated. And now it's just a matter of going from one to the other by diving into the macro implementation itself. I'll see you there. So just like in the last macro video, there are these 3 files. There's this little client where we're going to test our code. Then there is the package, the main package that we depend on. We import macrokit up here. And here's that stringify macro again. We're going to create our own, once more, an attached macro. We'll see what to put in there in a moment. And we wanted to call this, I think, derive any wrapper. And the implementation is going to be this external macro, macrokit macros, and then derive any wrapper macro. Last time we had to do a couple things. We wanted to add members and a conformance. I'm not entirely sure what to do this time, except there is this peer role that I'm pretty sure we'll need. And this will allow us to define, if I'm not mistaken, other elements. So we have this derive any wrapper. We can throw this here now to derive other declarations, to generate other declarations that are going to be siblings, here's, if you will, of the original thing. Last time we just added some new members and we added a conformance. This time we're going to be adding at least one peer. I'm not quite sure if we'll be able to add this extension, but we could try it as a peer. It's not a conformance, and any members we added, such as this, got added to the definition itself, but I don't believe we can add new members to a protocol, at least not members with bodies. So we'll see what happens. A little bit of exploration. Nonetheless, we have derive any wrapper. We're going to want to make a derive any wrapper macro inside of this macros file. So I'm going to say public struct derive any wrapper macro, and we'll now try what a peer macro appears to be. And we will add this to our providing macros, deriving any wrapper macro.self. So all of these macros have this expansion func. There's overloaded expansion function, this one. Let me pull all the members onto one line. Looks a lot like the member thing, except it says providing peers of instead of providing members of or what have you. It is the same arguments. They all have pretty much the same arguments of our attribute, what I keep referring to as the annotation. So this is going to be that literally deriving any wrapper, the syntax for that, which right now is quite useless to us. The declaration, which should be the protocol, and then the context, which is just a bag of utils that we can use for generating names if we feel like doing that. If we want some unique names, maybe that'll be fun to throw in there. Could actually be useful instead of doing those underscore methods. But we could generate unique names, so they're definitely not going to conflict with anything, but I'm okay with the underscore for now. So let's just see what we can return from this. Let's just make up some nonsense. I'm going to start with a struct here. So we'll say return, and we'll just throw a couple of declarations in here. So we'll just say struct cool thing, let nice int. Let's start with that. And this is interesting. I get an error here saying cool thing is not covered by macro derive any wrapper. And I'm guessing this is because we probably need those names here as yes. I'm going to say arbitrary this time because we actually don't know the names of the structs that we're generating ahead of time. It's going to depend on what the name of the protocol that we're wrapping is. So I'm going to say arbitrary here, and that works. Hooray. So we're just going to use that escape hatch. And so now if I expand the macro, yeah, there's a cool thing here. And if I try to print out a cool thing, can I generate this? Seems to be working. Yeah, we have a thing. I get this weird error here saying this struct may not be available in this context, but it totally is. So that's nice to know. Wonder if I make this public struct, the public initializer, if that will make any difference whatsoever. It does not seem to. Cool, and it seems to know that it is its origin lies in this macro here. So that's nice. Yeah, weird error there, but it'll work for our purposes at the moment. The next step would be to see if we can add that extension syntax. Can we add an extension for our type? I'm going to try that in a second argument here. Extension box for now. I'm going to say static var fancy string equals very fancy. And we'll see if anything explodes. No, a macro expansion cannot introduce an extension. So that's interesting. So I'm not sure if we'll be able to add that as any syntax. At least we can create the struct. All right, so with that minor disappointment out in the open, let us actually get started on the stuff we can write, which is this. So be it, we won't get the little as any extension method, but that's okay, we'll survive. So in here, I'm just going to drop in our comment so we can reference that, as well as this any implementation. It could be nice to have this easily visible as well, and we'll put that right here. So let's just start checking off some of these boxes, right? We want the protocol identifier. Let's get that first. So first we'll need a protocol declaration. I really don't like saying the word protocol declaration. So we'll take our declaration and cast this as a protocol decal syntax. I wasn't sure if that existed, but there it is. It makes sense that it does exist. Let's get the identifier. This should be protocol.identifier. Perfect. And this is a token syntax, which we can interpolate in a variety of ways. Or we can just call text on it to get it as a string, but we'll keep it as syntax. And now we need to get all of the associated types inside of this protocol. And in fact, wouldn't it be nice if we could do a very similar thing? Associated types equals protocol decal dot associated types. It looks like there's this thing, primary associated type clause. That's definitely not it. Let's just do dot associated types as though it already existed. Wouldn't that be nice? And now, with that goal in mind, we can jump below. And let's make some extensions. We'll make an extension on protocol decal syntax, call it associated types. And I'm actually not sure what this needs to be yet, an array of something. And let's see. I'm not exactly sure what we need, but let's try the following. Let's get our member block, because that's basically where everything in between the start and end curly brace of a declaration are. And that's where we put the associated types, right? Right, it's between these curly braces. So I think this whole thing is the member block. So it's bound to be somewhere in there. So let's get the member block, the members, compact map, and we will get each member where that member is. Oh, actually, probably I want to do .decal as, I don't know, associated type decal syntax.self. That seems reasonable. So this is going to be an array of associated type decal syntaxes. Hopefully that's not a lie. And to see what we have here, I'm going to use that trick from the first video, which is sort of hacky, but works, where we're going to interpolate using this raw prefix, just throw in a debug description. And then when we build, we'll get a compile error. If we click on that, it'll jump us to the expanded macro where we've just interpolated this debug description as code, which doesn't compile, but hey, we can use this as information. And it looks like the identifier is value, and that's exactly what we want. There's also this keyword. So it's basically the syntax tree of this thing. You have the keyword, you have the identifier, value. It even includes the space there for us, but we can get rid of that. In fact, I think it's automatically removed depending on how we interpolate this. So that's really all we need. What if I add another value real quick? Thing equals int. If I rebuild and click, yeah, there we go. There's thing. It now has an initializer. Type initializer clause syntax. Simple identifier syntax. Simple type identifier syntax of int. So yeah, that's the initializer part. So these syntax nodes really do closely mirror the actual lexical tokens that you've written here, which, as I kind of complained about last time, is fairly low level, does not give us much structure to work with beyond, well, what the Swift parser gives us, but that's why it's fairly hot off the press, hot off the parser press. Nonetheless, this is totally what we want. So let's remove first that new thing. So it's just what we want here. And good, now we have the associated types. Next, we need all function declarations. So that's actually not so bad. Function declarations, function decals, dang it, I said it. And we'll go down here, basically copy this, function declarations, function declaration syntax. And we'll do the same thing, except grab the function declarations. And let's now see what the raw function decals look like. This is going to look very silly. And we're also going to log the identifier. And let's see what awful code we've generated. Yes, the identifier is box. The associated types are just an array of that one value, and our function decals is another array, and it just has this keyword func identifier get, and it is a signature. The input is an empty parameter list between two parens, and the output is, in this return clause syntax, the arrow. Very important information there, and then the identifier value. So we'll be wanting the output's return type and the input's parameter list. That's definitely something to keep an eye on. Maybe I'll steal this from here, and we'll throw some extra comment here so we can look at that when we need it as we move our way down. So function name, that's easy to get. That's basically the function declarations identifier. So that's fine. The signature, let's its signature, though we know we wanted to generate a corresponding function signature, like a function value signature. So we wanted to go from func, for instance, in this case, get to value. We wanted to turn this into void to value. If it were a different function like add xint yint, and it doesn't matter what the labels look like, we don't care about that. Their function representation would be this. I guess to return an int as well. So we want to write an actual function that we can call at compile time that will translate this syntax, take in this syntax of a function declaration, and output the syntax of this function type signature, function value type signature. So let's do that. Function value signature. Make function value signature. How about that? And we can pass in a function declaration. I suppose we want them for all of them, but for now, let's just take the first one, because we know it exists in our example. And oh, this function doesn't exist, no problem. I'll steal our comments, drop down below, and I will make a private static function, make function value signature. We'll take a function declaration syntax, and we will return something. I suppose it'll sort of be a type syntax, actually. That's how we're going to use it. I know that syntax type exists from before. We could also return a string, really, and interpolate it in a raw manner, but all is good. Let's pull our comment below as well as this shape here. And now we can focus just on this piece of the puzzle. So we will need the inputs. Input. And actually, because it might be nice to know what'll happen when we actually have arguments, let me go back here and add function x int y string to Boolean. Let's make this nonsensical function here. Let's return an empty string for now so we can get this to faux compile. So we can look back here and see what our more complicated function signature looks like. We'll steal this for nonsensical, go back to our macro and replace this with that. Beautiful. Okay, we need to get our function declaration. We need to get a few things. Oh, we need its signature, and we need its input, and then its parameter list. And then for each of these, for each parameter, we need its type. Luckily, these are non-optional in functions, in function declarations. And that's basically it. So we'll have input types, and then we also want the output type. So function declaration signature.output. Ooh, seems like that is optional because, of course, it might return unit. If this doesn't return anything, we could have had some method that, did something mutating or side effecting that took in some message string, but didn't actually have any output at all. So that's why it's optional. But we can turn that into, if we were to see that, string to void, however you feel like writing it. So we'll deal with that. Nonetheless, output dot return type, that's basically it. Simple type identifier syntax. It looks like that's what that is. And then maybe I can say or simple type identifier syntax void. Will that work? I think I have to say type syntax here, which is fine with me. And there we go. So we'll either get the return type or we'll replace it with void. And now it's just a matter of constructing our composed thing. And this is actually a bit of a challenge. I'm not entirely sure what we need here in terms of what we need to write, because these are not strings exactly. These are type syntaxes. And unfortunately, there is no just .text. There's a syntax text bytes method, which will get us an array of bytes that represent the characters, which I guess we could turn into a string, but it's definitely not making it easy for us. Let's take a little look by doing the following. Let's have a simple method. Let's go back to nonsensical and have this return a function type. So I'll have a function from int to void, and that could be the return value. And why am I doing that? Because if we jump into this debugged thing, we could see what the return type is. It's a tuple type syntax. I'm not sure if, that must be that. Let me get rid of this wrapping thing. Click again. Okay, this is better. So what is this? What is the syntax of this function type, which is the sort of thing we want to represent? It's this function type syntax, and it has this tuple type element list syntax. Inside of it is the arguments, which just has one element here, and then its return type is a simple type identifier syntax. So who knows? This seems a little weird. Let me see what happens if we have multiple arguments to this function. Clicking on this. Okay, yes, so this tuple type element list syntax is basically what it looks like here. It's a sort of just this type tuple thing. Okay, definitely strange. I'm not sure how easy it is going to be to create one of these, but it's not so easy to do the string interpolation at this point, just because I would like to be able to join these fellows, and there is no joined function, though it's not the end of the world. I'm going to try this weird function type syntax thing. We need to construct one of these, essentially. So let's see if we can do this. Function type syntax. And we need this tuple type element syntax and the return clause syntax, which is exactly what we have in here. The arguments are tuple type element list syntax, and there's this. So let's try to solve these one at a time. Tuple type element list syntax. Gosh, that's a mouthful. Tuple type list element syntax thing. And we have a few ways of doing this. One seems to be an array literal. We can pass in a literal. Now recording over the video at a later date. You can see me struggling trying to find a constructor. There are many constructors for this tuple type element list thing, syntax tongue twister thing. And I try a few variations, sort of the combinatoric explosion of pass this constructor for the argument to this constructor for the container. And they continuously break until I finally stumble across a working combination after many tears. And that's what's happened. Because there was this type constructor. So now I'll put the type in here. There's a fairly long compile time right now, unfortunately. Tuple type element list syntax. Okay, that seems to have worked. That was fairly painful, but it worked. Next would be the return clause syntax. This should be easier. Let's throw this in here. This should simply be return clause syntax, and it should take a type. There's this constructor, and I really hope I can put the output type in here directly, and hopefully this works. Now, Unfortunately, this is not a type syntax. It's a function type syntax, so it's a different thing. Fine. It seems to have worked. That's insane. That is insane. Sometimes quite difficult to work with this stuff. Let me clean up a few things. I do not love these syntax types. So let's see what we get for our function value signature. In fact, I'll generate them for all of them. So I'll say function decals.map, make function value signature. We'll throw that in there, and then we'll add them here as function value signatures. And once that pre-builds, we should get this awful, increasingly large error message. But here at the bottom, oh yes, we're showing the debug description. We don't want the debug description, actually. This is where we want to see what it actually looks like. So we can just interpolate perhaps the first value of this. And there we go. Wow. That's truly awful. Let's take a look at the second value as well. That is not quite what we want in this case. It seems to have added a void before the oh wait, no, that is exactly what we wrote. We wrote a function that takes no arguments and then returns this function. So let's try to move this back to the way it was. X string to bool. Let me rebuild and check this out. In string to bool. Well, isn't that almost correct? It does not have commas there, which is somewhat insane. These are the real world troubles of trying to use these APIs. So it seems that by doing this, we do not have commas. Now, this means there's probably another way of writing this that will add that. But it doesn't do it itself. It's raw syntax, both in what we get and what we construct. It's pretty rough. This was sort of a low-level way of constructing it, though, by wrapping these nodes themselves. It would be great if I could turn this into strings and then just do full-on string interpolation in this case. But there's another syntax we can take a look at, which is this builder syntax, this result builder syntax. And I'm not sure if it's going to work, but let's try it out. So there's this thing, this items builder syntax here. And in this, it's kind of like if you used other result builders. Well, SwiftUI uses a result builder, though they have for reasons a special for each view for this type. But one thing you can do in these result builders is use a for loop, and it's somewhat magical. So you could say for input type and input types, I believe I should be able to say tuple type element syntax, then throw in our input type in here. I really hope this works. Good, a successful failure. And there we go. This added the comma. So by using this strange alternate construction syntax that looks like almost the same thing, except we've given it a trailing closure instead of parentheses, it takes care of doing some fancy things for us. There's this result builder thing here, and yeah, pretty wacky. It looks like there's this ensure trailing comma function that's called internally in this builder syntax somewhere, so that will help us out. So yeah, in this case, this builder syntax was useful. And yeah, you'll see this. There's this whole result builders file that has a bunch of them. Not every piece of syntax has one of these builders, but in this case, it was brilliant, and it's just what we needed. So tricky. Not everything is as easy to work with as it would ideally be. I wish this API were a little more consistent, but I think we have our function value signatures, or at least a function that gets them for us. The function name, that's trivial. That's just the identifier on each function declaration. Let me steal this again in case we need it. I deleted it because I was tired of looking at it. So yes, the function name for each of these should be quite trivial. The signature. And yet let's go to look at what we need to generate again. So where do we need to use these function signatures? We want to create each of these underscored declarations. And in fact, that's the only place we need the type, the signature type. So maybe we can make a method that generates these fellows, these little mason jars, in which we're going to store off the guts, the innards of our original protocol. So I'm just going to call these underscore values. And we're going to go through our function decals, map over these, take each one. And in here, we want to generate something like let underscore name, and then this special function sig. So this should be rather trivial. We have the name, function decal.identifier. Then we have the signature, which is not that signature, but the one we're going to get from calling make function value signature. Throw that in there. And now this should be really easy, actually. We could say let underscore name colon signature. I hope this works. And this is going to be an array of declaration syntaxes because we're defining a value here. And that seems to have worked. I'm going to clear out some of this information that we've already had. And let's take a look at underscore values 0 and 1 and see what we've generated there. And yep, that's exactly what we want for get and exactly what we would want for nonsensical if it were something we were actually storing here. So that's pretty great. And next we need to define the actual functions. So for each of these functions, we're going to basically use the exact function declaration, except we're going to add a body to it wherein we call the underscore variant. And maybe that's going to be very easy. So proxy declarations. So we'll go through each of these. I'll move this down here, function decl. And in here, we want to take the function declaration. Let's see if we can just string interpolate some nonsense here and basically just call underscore function declaration.identifier, open close parenthesis. Now, unfortunately, this isn't going to work perfectly because we need to also interpolate in here each of the function's arguments. But let's just see what this looks like for now. Proxy declarations 0 and 1. Hopefully it at least satisfies this as a decl syntax. Let's see what we have. And yeah, the formatting looks awful, but that's not really a big deal at all. But clearly for nonsensical, we need to propagate those parameters in here. And so for the functions with arguments, for instance, nonsensical in this case, so it looks like there's this first name property. However, let us change this just a little bit. What if we had an underscore here, or from string, one of these types of functions, and then other int down here? So these are all things you can do in Swift. You can have underscore prefixes, these labels, and then the internal values. The values in white here are the ones that you would reference in the function body, where these are sort of external labels. So we want to make sure we call these names. However, it's a little weird because in the case that there isn't a sort of second name, you want to refer to it by the label, both internally and externally. So if we go back here, let's interpolate once more the function declarations, build, peek at our noise, and steal this confusing thing. Maybe this will help us understand our dilemma. Maybe I'll keep this weird highlighting for commenting it out. And I will steal the function signature. Sorry for all the back and forth. So we can see here that now X has a first and second name. The first name is wildcard, so that gets a special value right there. And then the second name is actually what we want to refer to it as. So there's this optional second name on each function parameter. And if that exists, we want to use that. We'll have to reference that in here. Remember that they're going to be defined up here. It's weird. So if I write string here, that would reference this value. We kind of want to call this like this, X string and then other, because the first name here is other and there is no second name. So we want to go through each of the function parameters, get the second name, or else nil coalesce, grab the first name, and then we want to turn this into this tuple list thing. Now, luckily, identifiers are easily stringifiable, so we can just do some string interpolations. So let's get the params. So I'll say function decl dot signature input dot parameter list map param in param dot second name, and I will get the text of this, and I will actually trim this to remove the white space. Not that really matters. Or else param, in fact, let me do it like this, param second name, or param.first name, and then we'll just get a list of strings here. Strings are delightful to work with and truly not that much less safe than these syntax nodes. As we've seen, we were able to interpolate this into our code as valid Swift syntax. As we've seen, cannot use optional chaining. I think we can. I just needed to have my space there. Perfect. Okay, so now we should just be able to take this, and now we can take this and interpolate in a raw fashion a lovely method like joined separator comma space. And now let me rebuild, click onto here, scroll way down, and we'll see that we're calling nonsensical sensibly, which is a beautiful thing. So now we're 2 steps of the way there. We have our little storage underscore prefixed values, let's there. And then we have these proxy function definitions that forward to these stored values. The next thing we'll need is, if I scroll down to our any box, is really just this initializer. And that's it. And then we're done. I didn't actually write any notes for this one, so let's delete all our awful noise and finish this up. So we need our initializer. What is this going to look like? Well, I'm guessing this is going to be another declaration syntax. We're defining an initializer. I'm not quite sure yet. I doubt it matters. We'll see what happens. So I'm going to say initializer. Then we'll need some value here. Maybe this is where we can make use of something we have never made use of before, which is this context. And we can have some type param, and I'll say context dot make unique name, and I'll just call it, I don't know, T for type. I'm guessing it's going to give us some kind of suffix or prefix. I don't know what's going to happen. We'll see. And we'll say type param in here, colon, and then we want our identifier. We've already stored that off. That will be box, the name of our protocol. And then we need this. And we need another unique name. I'll call it proto. So we want this protocol value. Proto, throw that in there, where that is a value of this type parameter. Lovely. And then we want where for each associated type, yes, we've grabbed these associated types. I don't think we've actually used them yet. The purpose of them is to basically map over them and say where this equals this and have a comma-separated list of that. So this is a great job for string interpolation. So let where constraints equals associated types. We'll map them, associated type in, and here we can say type param dot associated type equals associated type. And then we want to join these with commas. And then I'll say where clause equals if associated types is empty. Rather, if associated types is empty, we can just have this be an empty string. Else, we'll have these joined where constraints prefixed by a where. Pretty exciting. And then we'll throw our where clause down here. And fatal error. Let initializer. Oh, yes, it's up there. What have I done? Let's see how sad this is with what we've done. Oh, I'm doing a strange combination of syntaxes there. I'm sure everyone's scared and confused. Throw our raw down there. And let's now put our initializer in here. So init initializer, and I don't think I need to say raw actually. Let us think and see. Oh gosh, that is truly a random name. And I can see a couple of mistakes here. First of all, I need to get the identifier of the associated type. I don't care really about anything else. So down here, in both cases, I'm just going to grab the identifier so we don't have that keyword. That name is really unique. That is such a unique name, but I don't really want to have any sort of conflict. Gosh, maybe I can say token syntax of _t, and this one can be token syntax of _proto. So it's a little more readable for our sake. Maybe not as safe, but Lord, that was too much noise. Okay, yeah, beautiful. That basically is what we want. For that first line. Pretty cool. Hopefully that actually works with the underscores. I think that's valid code. Okay, so we'll keep these for now. Hopefully in your code you do not define these types in some way that would ruin this macro. So now we need the final piece, which is to basically just project out each function, just go through each function parameter, and this should be really easy. That's all we need. So let assignments equals function decals to map function declaration in self ident equals function declaration dot identifier. Basically, it's the name self dot name with an underscore equals that awful proto name. And then we want to join these with, I don't know, new lines and then interpolate it as assignments. And we've truly created some monstrous code in here. I'm going to delete some of these awful comments. It's giving me a lot of stress. Wow, look at that. That is quite a piece of work. And now we'll try to get this to work. So what do we want to return? We want to first return the initializer, and this is all for the initializer. But we also wanted the proxy declarations as well as the underscore values. And I believe that's everything. Oh, but of course we're defining a peer. So yes, it's not quite everything. We need to define all of this inside of our anytype. I forgot about that important part. So the innards are great, but these are just getting dumped out into the top level. We need this final bit. Oh yes, almost forgot. So now we're at the last thing. I keep promising this, but we truly are at the home stretch. Let us remind ourselves of what we need. Struct anybox value box. Perfect. And now I will go back to triple multi-line string syntax. Struct any identifier, identifier. And then of course we need to comma separate all of the the associated types. So I'll say associated types, map, identifier.text, joined, comma space, and that's going to have to be raw because it's not a piece of syntax. And that's truly awful what I've just done, but I'm going to keep it. And then inside of here, we want the initializer. And then we want some groups of things, some new line separated things. I think in order to do this, I can actually just, this is not pretty, add, let's see if this works, the proxy declarations plus the underscore values plus that closing curly brace. So a truly horrific thing I've done here. Invalid redeclaration of any box. I like this. Let me kill this real any box and see what happens. Okay, things seem to be happy. Expand the macro. It looks truly abominably formatted here, but technically, if I were to copy paste this, God, that formatting is awful, and run it through my formatter with my little shortcut there, this is valid code. And if I comment it out, comment out the macro rather, and run this, the code works as before. So let me comment out that code, add the macro back, drop down here. And then, of course, I did mention we unfortunately were not able to add extensions. I hope they add that ability, because that sure would be nice to have a macro add some special syntax. And, with as much as these macros let us do, I can't really think of a good reason why they wouldn't let us do that. But hey, this is fine for now. It's also a little weird, additionally, because I don't get syntax highlighting, at least not in this file. Maybe I would if I consume this from elsewhere. So yeah, a few problems, but I at least hope. Oops, I never needed this, but I at least hope this long and painful process showed you some, techniques for understanding, working around the rough edges of the system. The fact that you need to sort of use this builder syntax sometimes, keep on the lookout. The weird juggling between string interpolation and syntax interpolation. Maybe there are better ways of doing this. Comma-separated arguments in this type parameter list. There's probably a piece of syntax for that, but honestly, as we saw, if you use the wrong constructor, it's actually not going to work. So using join, separator, comma, space is just, that's a surefire recipe for success. I hope this builder syntax can be, a little better documented somewhere. Anyway, it's fun. Macros are fun. This is a weird project, but I hope it helped. Enough qualifications. I am logging off. Goodbye. Oh, and like and subscribe. Yes. Yeah, do that if you want. Or block me and report. Block and report. Goodbye.